We're going to be graphing linear equations in two variables today, and if you remember last time we started with this equation, y equals 2x plus 3. We're going to graph it over here on this small little coordinate plane that we have. And we came up with a few points. I'll show you how we got one of them. Remember, we plug in, we say, okay, let's try it when x is equal to 0. Let me make my table over here first. We've got our x, y chart, and then, as I said, the book adds a little bit extra. They add the ordered pair here from the x and the y. So let's just plug in, and let's say if x is 0. So if x is 0, I'll plug in for x, I'll plug in 0. And so now we get y equals 0 plus 3, or y equals 3. So when x is 0, y is 3, and that gives us the ordered pair 0, 3. Okay, I'll put a few more points on here, and then we'll keep going. Okay, so I've added a couple more points. I calculated when x is 1. Down here, I got that y is equal to 5, and then here's my ordered pair 1, 5. And when x is equal to negative 2, down here, I got that y is equal to negative 1. So we've got the ordered pair negative 2, negative 1 from that. So let's graph those. We'll put them in red. So we've got 0, 3. So that's going to be here. So remember, we start at the origin here, and you're going to go 0 units in the x direction, and then you're going to go 3 units in the y direction. So that leads us to that point right there. Next one, we're going to do 1, 5. So 1, and then 1, 2, 3, 4, 5. So that's up here. And so the way I got to that point is, again, I start at the origin, and then I go over 1 unit in the x direction, positive x direction, because it's positive 1. And then I'm going to go 5 positive units in the y direction. 1, 2, 3, 4, 5. So that's how we get to that point. And the last one, negative 2, negative 1. Start at the origin, negative 2, negative 1. So we're there. And the way I did that, start at the origin, negative 2 units in the x direction, and negative 1 unit down in the y direction. So that's this point here. And let's go through and we'll just label those. So this is 0, 3, 1, 5, and negative 2, negative 1. Okay, so we've got our points labeled. And what you'll notice is that we have these points. They're starting to form a straight line here. And in fact, if we calculated a whole bunch more points, they would all be along this line here. So the solutions to this equation here, the solutions to that equation create a line. And that's the solution to a linear equation is going to be a line. So let's just, what we'll do is we'll draw a line. I don't know if I can draw it as straight as I should, but I'll try. So it's going to go like this. Okay, and it's going to go on forever in this direction up here. It's going to go on forever that way, so we put the arrow on the end, and then it's going to go on forever down this way, and we put the arrow on the end down here. And this graph, every single point along that line, it represents a solution to this equation. And if there is a point, say, let's say there's a point out here, this point here, if it's not on this line, it is not a solution to this equation. So the only solutions to this equation are on this line here. So what we have here, I've got another equation, y equals 4x minus 1, and I have 3 points over here. Now what we want to know is whether or not these 3 points represent solutions to this equation. So remember from last time, if you plug in these points and they create a true statement with the equation, then they're solutions. And there's another way to do that as well, and we'll see it on the graph. So what I'll do, I'll graph this y equals 4x minus 1 over here. And then we'll check to see if these are solutions by plugging them into the equation, and we'll also graph these points over here with the line, and we'll see what happens with that. Okay, so what I've done is I have plugged in 0, negative 1 into this equation. So negative 1 goes in for y, and 0 goes in for x, and then I evaluate it, and I get negative 1 equals negative 1. So that's a true statement, which means that 0, negative 1 is a solution to this equation. Same thing with 2, 7. That was a solution. It checked out. and then when I plugged in 3, 5, it did not create a true statement, so it's not a solution. So let's see what that looks like on our graph. So I'm going to graph, I'll put these in blue. So 0, -1, actually I'll do different colors for each. So 0, -1 is going to be blue. 2, 7 is going to be green, and 3, 5 will be yellow. So 0, -1 is right here, right on our line. And then 2, 7, we'll go over 1, 2, 3, 4, 5, 6. 7 is up here. Oh, wonderful. This would continue on 1, 2, 3, 4, and actually go right through that. So that 2, 7 is on our line as expected because it is a solution. Remember, the line represents all of the solutions to y equals 4x minus 1. So if a point is a solution, it should be on our line. Now this one, 3, 5, was not a solution. And so let's graph that. So we got 1, 2, 3. So that's right here. Notice it's not on our line, which is also expected because it's not a solution to our equation, okay, as we saw here. So this is similar to something that'll be on your practice set tonight. So this just says graph by plotting points, and all they're going to do is give you an equation like this: y equals -3x plus 1. And so I've got my coordinate plane over here ready to go. And what I'm going to start off doing is I'm going to create a little table, and I'll do x, y, and then I'll put my ordered pair x comma y here. So what we're going to do is we just come up with our own x's, and I'm going to come up with x's that we'll try to make them fit on our coordinate plane, obviously, to make it easy on ourselves. We can always change the scale of this if we want. Instead of counting by ones, we could say we're counting by 2, 4, 6, 8, 10, 12 if you need more room. So you can always do that if you need to, don't forget. And just be sure that if you do that, you have to, like if you count by 2s on the x-axis, make sure you're counting by 2s on the y-axis as well. It'll make it much easier for yourself. So I'm going to just start with 0. 0 is always, I'm going to plug in 0 for x. It always is an easy one. So let's do that. So we've got x equals 0, and we'll plug in for y, or we'll plug in for x, and then we'll solve for y. So I've got this. So that means y is equal to 1. So when x is 0, y is going to be equal to 1, and that's going to give us 0, 1. There's 1 point on our line. All right, let's try another one. I'm going to I'll plug in 2. So x equals 2, and we're going to have y equals -3 times 2 plus 1. So that's going to be y equals -6 plus 1, so y is equal to -5. So when x is 2, y is -5. Whoops, forgot to do my ordered pair. So I'll have 0, 1, and 2, -5. So I have 2 points now. 2, -5, 1, 2, 1, 2, 3, 4, 5 is right here. So there's 2 points on our line. Now we could graph this because you really only need 2 points to graph a line, but I strongly, strongly, strongly recommend you get 3 or more points, because let's say I graphed these 2 points and one of them was wrong. I could still graph a line, but it would be the wrong line and I wouldn't even know it. Let's see what happens when I get my third point. So let's do it the third point. Let's just pick, let's choose -1. So we'll do when x is equal to -1, what do we get? So we've got y equals -3 times -1 plus 1. So this is going to be 3 plus 1, so that is y equals 4. So y is 4 when x is -1, so that's -1, 4. And if I plot that, -1, 1, 2, 3, 4, so that's right there. So now I can see clearly, okay, the first 2 points look like they're in line with each other, and they're agreeing with this third point that I have here. Had I say one of these was wrong, like it was over here, and then all of a sudden I'd have a point here, here, and way over here, and that's not in a line. So it's getting a third point is a good way to just verify that you've got everything correct so far, and you've got things going in a line. So 3 or more points minimum, or I'd say 3 minimum. So there's my line right there. Okay? I have successfully graphed that linear equation. All right, we got 2 more, and I'll try to make these quick. So this one here, x equals 4. X equals 4, this is like a special case kind of, and when we go to make our graph, or our table of points, we've got x, y, and then our ordered pair x comma y. And remember, if you look at this, the only thing that's going to make this true is if x is equal to 4. So it really doesn't matter what y is. X has to be 4. Always. X is equal to 4. And so y can be anything. Just anything I want as long as x is equal to 4. So I've got 3 points already. 4, 0, 4, 1, and 4, 2. So if I graph those, I'll have 1, 2, 3, 4, 0, 4, 1, and 4, 2. So I have what ends up being a vertical line here. So anything like this, where x is equal to 4, is going to end up being a vertical line. Okay? Same goes for this one. So what if we have, y equals, say, negative 2. Let's we'll make our plot here, or our table. So x, y, and then x comma y. And again, in this case, it doesn't matter what x is. X can be anything. Y has to be equal to negative 2. So all my y's will be negative 2. And then my x's can be whatever I want. I'll just do 0, 1, 2 again. And so now I have generated 3 points. I've got 0, negative 2, 1, negative 2, and 2, negative 2. Anybody else bothered by this gap? Yeah, me too. Let's fix that. All right. 0, negative 2. 0, negative 2 is here. 1, negative 2 is there. And 2, negative 2. There is the line for that one. So this one, the blue, is y equals negative 2, and the red is x equals 4. So this one creates a horizontal line here, and x equals 4 creates a vertical line. Remember, the way you can remember if it's vertical or horizontal by the word. Horizontal, horizon is flat, the horizon is flat, horizontal is going to create a line like this, and then vertical is this way. All right, that's it.